For quantitative data versus for categorical data, we actually need to look at more aspects of the data than we do for categorical. So for quantitative data, we want to understand four aspects of the data distribution: the shape of the distribution, the shape of the data effectively, the measure of center, in other words, that typical or representative value, variability in the data, and any unusual observations. And we're going to look at each of those aspects individually. First, we're going to start with shape. So what do we mean by shape? Well, let's take a look here. We've got an example of exam scores. So let's say these are from um, some class, could be any class. And what is plotted here is actually, these are called histograms. So looking at these here, these are all histograms. For quantitative data, we can find out about the shape by creating a graphical display, a histogram, which is what's shown below, or a dot plot. We'll see an example of the dot plot later in this note set. I personally, if I'm doing it by hand, I'll use a dot plot because histograms can be a little bit of a pain to generate by hand. Usually you're going to notice that these are generated using a piece of software to get the ones that are these possible shapes for exam scores. So let's talk about what these shapes are and how we identify them. Well, let's start with the one that is probably most familiar, and it's the bell shape and symmetric. So looking at here, we see that this is roughly symmetric. When we say symmetric, it doesn't have to be perfectly symmetric, but I could draw roughly a bell shape that would capture the vast majority of the data. So we're going to use this shape a lot throughout the course, but for right now, we can see that this is pretty bell shape and it's pretty symmetric. A uniform distribution, on the other hand, means that all of the outputs are the distribution is roughly the same. We're going to notice, also looking at these in general, that once again, the X and the Y axes are labeled. The ones that tend to goof people up are the left skewed and the right skewed. Left skewed, people are like, well, this is left skewed. Like, well, wait a minute, but all the data is on the right. Correct. What we're looking for, and when we talk about skew, is where the weirdness is. And the weirdness is down here, right? These are some unusual observations. Right skew, on the other hand, is the same idea. You can see there's a couple up here, and these are called right skewed. And left skewed, right skewed, that's what these will become very useful when we start talking about whether to use mean or median for our average, which we're coming to soon. Notice, just to wrap it up, that the X and Y axes are labeled. You may say, well, okay, what would these bars total if I added them all up, if I knew the exact values of the bars? Well, remember, we're accounting for everyone in the sample, so the bars would total 100%. And if you wanted to do a rough add, I should add here, you could say like, well, it's 48 plus, and if you added these up, you'd get, it's hard to see it, but it would end up being about 100%. So there's the shape of the data. Now, measures of center, in other words, that typical or representative data value, when describing quantitative data, we usually report a summary number, a statistic, that's typical or representative of the data distribution. This describes the location of the center of the data. Two measures that we look at are mean and median. Now, honestly, we throw around mean all the time, but mean may not always be the best thing to use. So we want to make sure that we understand the difference between mean and median. So mean is simple. It's just average. It's the balance point of distribution, and we should be able to determine the approximate location of the mean without computing anything. Looking here, we're going to look at these, the non-skewed two distributions. The center we can see is probably right about here. Okay, quick and dirty, we can see it. Well, these are everything is pretty uniformly distributed here. I'd say the center is somewhere around here. And that would just divide the data in half. Let's stick with that. On the other hand, median divides the sorted data in half. Here, if I tried to find the average and I added up all the individual data points and then I divided by the number of however many student exam scores there are here, the problem is most people scored, oh, let's say up in here. But we do have some weirdness. And let's think about what's that going to do to the average? Is it going to pull the average up or will it pull the average down? It's going to pull the average down. Okay, so we can see the average is probably, you would think it would be up here just looking at this, but then we've got these other numbers, these smaller numbers that are going to pull it down. If a data distribution is symmetric, then the mean is about the same as the median. So if we have a symmetric distribution, we are going to use the mean. Looking in more detail at the distribution that we had above. Is this roughly symmetric? Well, we said yes, it's symmetric. Remember, symmetry doesn't have to be perfect. It just has to be roughly symmetric. Where's the center? I'd say the center is right about here, roughly. What is that? Well, that's about, I'm going to say it's about 73. Oops, let me make that a little bit clearer. So what's a typical exam score? A typical exam score would be about 73. Okay, cool. On the other hand, let's look at a different example. What if the data distribution is not symmetric? And here we can see that most people paid between $0 and $120. The vast majority paying, oh, somewhere in $20 to probably $60 range. But there are some people who paid $160 for a haircut. I'll be honest with you, I've been there. Yes, I have. Is this left or right skewed? Well, hopefully you see the weirdness is the 160. So that is right skewed, okay? Because the skew is where the weirdness is. So we thought it was skewed right. If we calculate the mean is $45.68. Well, okay, I guess, but it seems like most of the data is in this area here, so I would expect it to be lower. If I calculate the median, which we'll figure out how to do in just a moment, that median is quite a bit lower. It's $35. Now, the median takes sorted data and finds the center of that sorted data. So things like this do not affect it, these large values on either end, whether it be a large or whether it be, in this case, going back up, we have some large data here, or we have something down here, a very small value. We're going to notice that here, if it's skewed right, the mean is going to be greater than the median. What if it's skewed left? What do you think would happen if I'm comparing mean and median? Well, comparing mean and median is going to be just the opposite. And if you think about it and look at those, the previous page of note, you see that makes sense. So the mean is influenced by outlying observations in a data set. The median is not. So we say the median is robust to outliers and a better choice of the typical or that representative value when the data distribution is skewed. And you may say, well, could these numbers actually be considered close? Yes, they could, depending, let's say we went up to hundreds of or thousands of dollars, these means and median could actually be close, but how would I know that there's actually skew and I should actually use mean or median? So if there's skew, I should use median. That's why we want to look at the data distribution itself. So it's not enough to just look at mean and median and say, well, those are different, so I need to use the median. We don't know. Everything's in context. But here I can look at that data distribution. So looking at that shape that we talked about earlier and say, oh, okay, Well, yeah, this is a skewed distribution. These are different. I should use the median. Let's do a quick example. Find the mean and median for each data set below. Which one do you think, which one do you need to use the median for to get a good sense of a typical value, and why? So how would I find a mean? Let's review. To find the mean, whoops, we're going to take the numbers, add them together, and divide by the number of points we have, which is 5, and the mean is 3. The median, on the other hand, is going to be, pardon me, is that typical value. It's the value that's right in the center of the sorted data. This data is sorted. So let's see. That means the median is going to be also 3. Okay, cool. Take a moment, do number 2 yourself, and then come back to check your answer. So hopefully you see, whoa, that 20 did affect that mean. The mean is quite a bit higher now, but the median did not change. Looking at number 1, is it skewed? Well, 1, 2, 3, 4, 5. No, they're all 1 apart. If I plotted that out, it would look just, they would be 1, 2, 3, 4, 5. Okay. What if I did it for number 2, though? 1, 2, 3, 4, and then I'd be way out of 20. There'd be a data point. So hopefully it's very clear. Is this skewed left or right? Well, it's skewed right because the weirdness is on the right-hand side. Just as an aside, or as an additional little example, it was very clear here that the center, the median, would be right in the middle. We have an odd number of data points. Well, what if we had an even number? 2, 4, let's say 6, and 8. What's the median of this? What you're going to do when you have an even number is go to the 2 center data points and then average them. So you average just the 2 middle numbers. Once again, though, you will need sorted data.